Okay, the question is obtain the inverse Laplace transform of the function given over here. The first thing what I would do, I would try to see if I can factorize it. But in order to do that, you can write down this formula. You see, quadratic formula minus 2 4 minus 4 ac over 2 minus 1 plus minus 3 iota. You see my point? How? So we are able, this is very helpful. If you see the denominator is not like a discrete root, multiple root, but it is a complex root, then it's another case. The third case is when you see the denominator has a complex roots, or in the Laplace domain they are located as -1 and 3 is plus 3j, or iota minus 3 iota, and these are complex conjugate in the Laplace domain, j omega t. Okay, now let's see how. So the first root is, can I write down like, can I split up into two functions, like can I write down like this? So correct, I can write down like this, correct. Now if you multiply these two terms, what do you get? You get this answer, s plus 1 whole square minus, why do I actually this should be minus sign iota square. Why this is so, let me show you. Probably you might get confused here. Let me show you this answer. Like, do you remember in your high school you learned, like, if you have two factors like this, a plus b times a minus b, what do you get? A square minus b square. Do you get the same thing? So it's a, this is my a, okay, this is my b. So if I write down a as s1 plus s plus 1 whole square minus b as 3 iota whole square, now you do understand, now is more clear. So what is, I will write this down like this, and negative 3 times it is just 3 squared iota square. Iota, what is iota square equals to? -1. So it would be like s plus 1 whole square plus 9. Agreed? Do you understand this now? Or I will just keep it like 3 square. The reason why I'm keeping it square, I'll tell you in a bit. Okay, let's write down the formula again. The question again, I'm going to write down the question here, the Laplace domain. S over s squared, is it s? Yes, s over s squared plus 2s plus 10. Now you would see I can write this down as, when you do the partial fraction inverse Laplace is always found by the partial fraction expansion. This is important. So you have to understand that if you see the denominator is 2 degree, power is 2, then you must have a 1 power less than the denominator degree in the partial fraction expansion coefficients. Probably you might have done this in your earlier classes. This is important to understand this. So now I want to show you, I can write it down. I want to find out what is a, what is b. So let's do this. A s over s plus 1 whole square plus t square plus b over s plus 1 whole square plus 3 square. So I'm splitting it up. Now I will do the multiplication. I'm gonna multiply the both side by the this denominator. Let's do this. So let me show you what I'm going to do here. Multiply both sides by the denominator of the left hand side, s square plus 2s plus 10. Now you will compare the coefficients. S left hand side is 1, it is A. For S 0, left hand side is 0, it is B. Agreed? So let's write it down. The left hand side, f of s equals to A is 1, so s over s plus 1 whole square plus 3 squared. B is 0, don't worry about B is 0. Okay, now up until here everybody is clear. Now from here onward I want to show you this table. This is important to understand the table, and you will learn slowly, or you might have done this earlier. So I'm going to copy this table here and to ask you which row number is the best fit for our case. So let me zoom out a little bit. So let me bring this down. Can you think of, now if you guys take a look here, which row number is it? Number 10, number 11, number 11. One student says number 11. Let's go with number 11, which is very close to what we have. Okay, but here there is a problem. In the number 11, the denominator has a different s. This s should be the same as s. So if I bring s plus 1 here by negative, but we have to do some manipulation in the numerator to keep the form in the denominator same. So I'm gonna write down s plus 1 minus 1. It's not gonna change the problem. So this term is the same. So now this term is, what is the answer? The cosine omega t. I will show you the inverse Laplace later on. So let me write down this separately. S plus 1 over s plus 1 whole square plus 3 square. This is 1. Okay, why am I doing this? It looks like 2 plus signs, so this is plus 1. Now minus 1 over s plus 1 square plus 3. So you see this negative sign. Now you have to do the inverse Laplace transform. For this case, you see this omega is equal to 1. So in order to bring this 3 in our numerator, you have to multiply it by 3 divided by 3. Okay, once you do that, then this term is very close or the same term like this one. So if you take the inverse Laplace, what do you get? 1 over 3 is for the 1 over 3 is the scaling factor. This 3 is the scaling factor. The remaining term is what? Is 3 the sine 3t. But here there is a problem. This negative sign, you will see it is e to the negative t. Why am I writing down? There is a way. So I will show you in a bit the formula here in the table. If you have some delay in the function, that delay can be compensated by e to the negative t. So this is the, yes, this is the form. So if you see row number 20 and row number 21, it is the same row, the same shape what we have in our case. That's why I wrote down e to the negative t. And for this case, it is same form like this. So if you take the inverse Laplace, what do you get? E to the negative t cosine 3t, and the total answer, the complete answer is this one. And in the, if I plot it, although this is not required, but just to show you, when you see the sine cosine function, they are like waves. Sine cosine functions are the waves. But here, this, when you multiply with the e to the negative term, this wave depresses after a certain time. So this is e to the we call this as envelope. Envelope decreases, so the net result for the wave is initially is very big, then it becomes small, 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 so it becomes so small that it it becomes stable. And if you see the exponent plus t, and you know what is the effect of plus t, the envelope becomes so big that it becomes unstable. The same sign in cosine wave, they start from a very small amplitude, very small amplitude, then they become large. And for e to the plus, if you multiply this or this with e to the plus t, then system is unstable. We call this as unstable system. Here, this is a stable system.